So chapter 8, we're dealing with what is called deductive arguments, but more specifically, we're going to focus on categorical logic. Categorical logic. And as I mentioned, this approach to logic was initially developed by the ancient Greek philosopher Aristotle. It's often called Aristotelian logic as well. And the idea is that it can help us to understand the nature, the basic nature of some of the arguments that we run across in ordinary language. You'll notice that the arguments in this categorical form are going to be quite formal in their presentation. And what we'll need to do is take arguments from ordinary language and translate them into the form of categorical logic. But the idea is that by engaging in this translation, we're going to clarify the implications of the arguments that we construct. Now, these examples are intended to show that it is not easy. Figuring out the logical implications of ordinary language is often not very easy. Consider these examples. Number 1 and number 2. The question is, are these equivalent claims? And as we'll find out later in the chapter, equivalent claims are claims that either mean exactly the same thing, or they have the same truth values. And that's an and. They have the same truth values. They're going to be true in all the same situations. They'll never have different truth values. So the question is one equal or equivalent to number 2? Everybody who is ineligible for Physics 1A must take Physical Science 1. Number 2 states, no students who are required to take Physical Science 1 are eligible for Physics 1A. Are they exactly equivalent?
No.
Correct? They are not equivalent. It is not exact. And, well, how about this next one? It's a little easier for you. Harold won't attend the meeting unless Vanessa decides to go. Is that the same as saying, if Vanessa decides to go, then Harold will attend the meeting?
Yes.
Not quite. Not quite. Harold won't go unless Vanessa decides. But there could be another qualification, There might need to be punch there too. This is what we would call a necessary condition for Harold to attend the meeting. But it's not necessarily a sufficient condition. He might need more conditions. Now, the point of these examples is to show you it's not so easy to narrowly describe the meaning of premises in arguments. And Aristotelian logic is intended to help clarify the logical implications of our arguments so that we can have a better understanding when claims are equivalent and when they are not. Now, here's what categorical logic is all about. These are what we call categorical claims. And they make claims about a class or category of things. And all of categorical logic is based on these statements, statements about categories or classes. The standard form is articulated here. And you're going to put the premise and the predicate and the subject in these blanks here. All S are P, no S are P, some S are P, some S are not P. These are going to be the 4 fundamental forms of categorical statements. Now, you're going to have terms where those blanks are. And the terms that go in here first, you're going to have the subject term is the phrase that goes in the first blank, and then the predicate goes in the second blank. So the subject's going to go here, the predicate is going to go here. This gives you an idea of what happens in each of these claims. In an A claim, when we say that all S are P, all S are P, we're referring to the white section here. And what we're saying is that if all S are also P, and so S is going to be solely in here. So the white portion is saying where we have objects. And if it's in S, it's also in P. So the red is going to refer to where there's nothing. There's nothing in here. How about the next one? No S are P. So there's nothing in here. But the white shows where you have objects. And so if it is an S, we know that it's not a P. So there's nothing in the S and P area. You see how that works, these Venn diagrams? Okay, now it's a little different when we go to some SRP. Here we're going to say that there is at least one in here. And so we're saying that there is at least one object in this domain where we are both in S and P. Now, how would we do it if we say that some S are not P? Where would this X go? Some S are not P. Very good, Matt. Right here, right?
Yes.
Exactly. It doesn't have to be red. Actually, it should be white, but you can't do it white, so black. So these Venn diagrams give you a pictorial illustration of the nature of the claims that these categorical claims, what they're referring to, and how the classes relate to each other. The first, on the left side, well, no, I should just say A and I claims, which are this one and this one. These are affirmative. They affirm something. All S is P, some S are P. And so you're saying what is, in fact, the case. Negative claims, we're saying what is not the case. No S is in P. And so these are what we call negative claims. Some S are not P. You're saying what is not the case.
Come again.
What's that?
The last one you said was, or some, okay. So E is a negative and O is a column.
Yeah, you're right. Here's the negative part of that one.
But E is a negative term. E, no S and P are negative terms. Then O is what? Some.
What's that?
I didn't get the last sentence.
Some S are not P. So these are both negative claims.
Oh, okay.
These are positive claims. So the key is going to be being able to take arguments from ordinary language and translate them into the standard form of categorical arguments. And as I mentioned, claims are going to be equivalent if and only if they would be true in all and exactly the same circumstances. If they're equivalent, they're meaning the same thing, essentially. And all standard form propositions, claims, are going to be in the present tense. Now, you can actually talk about the past when you do this, but you're always going to do it, oddly in the present tense. Here's an example. Some creatures that lived in North America, that lived a long time ago, are. We're not saying that they were. We're saying that they are. This is present tense. So the phrase can refer to the past, but the statement itself and the verb are going to be present tense. Some creatures that lived in North America are creatures that weighed more than 4 tons. So all statements translations into standard form, categorical claims, they're going to be phrased in the present tense. Now, the first step when we begin this translation into the standard form to A, E, I, and O is to identify the terms. And that's going to be a key step here. We need to identify what's the subject and what's the predicate. And they give you ammunition for being able to do this. Consider this example. Only sophomores are eligible candidates. Only sophomores are eligible candidates. Now the terms here are sophomores and eligible candidates. Now the question is, which one is the subject and which one is the predicate? Also, the question is, which form of categorical claim are they going to fit into? A, E, I, or O? Second step is going to be to identify the claim. Which A claim is correct. All sophomores are eligible candidates. Now you got to pick which one's correct here. All eligible candidates are sophomores. Which one is correct? I just gave you the answer.
B.
Very good. All eligible candidates are sophomores. Is that you, Vivian? Very good. Very good. Very good. It's the last version. Now here's the key. The restriction is placed on the class of eligible candidates. So it is the subject class. And now think about this. Only sophomores are eligible candidates. So you're limiting the number of eligible candidates. Well, if that's the one that you're limiting, then that needs to be the subject class. It needs to go first. So when you're thinking of which one's the subject, which one's the predicate, what you need to look for is where is the restriction being placed? Which class is being restricted in its size? And that term is going to be going into the subject area. That's a key for being able to translate. Does everybody understand that? I know it's a little tricky. Just remember that the subject class is going to be the one that is restricted. We can come back to that if you have any questions. Now here are some other keys for being able to translate from ordinary language into the standard form of categorical claims. All claims that take the form, the only X's are Y's. Whatever X and Y are here. That should be translated as all X's are Y's. And that would be an A claim. So anytime you hear the only unmarried men are bachelors, you're going to translate that into an A claim. Question, Greer?
So like with the last example where you said only sophomores are eligible, wouldn't it be the other way? It would be all Y's or X's?
Let's take a look here. What they're saying here is that the only X's are Y's. The only X's. Now, here, let me clarify. They're actually going to go and say the word only used by itself is going to introduce the predicate of an A claim. If you use the only, then it's going to become the subject of an A claim. So that's going to be the difference that would apply there. I know it's a little tricky, and initially it's going to be a little difficult to get familiar with this kind of translation. But I have in mind taking a bit of time with this chapter to make sure that we all can figure it out. So, once again, if you have something that says the only X's are Y's, you're going to translate that into all X's are Y's, an A claim. But if the word only is used by itself, then it introduces the predicate term of an A claim. The only will introduce the subject term of an A claim. Let me give you an example here. Only matinees are half-priced shows. Can somebody translate that into standard form for me? Only matinees are half-priced shows.
All matinees are half-price shows.
Not quite. Think about this.
The only half-price shows are matinees.
Half-price shows matinees.
All half-price shows are matinees. Very good. You're on a roll, man. Rolling on. Because we're only, by itself, is introducing the predicate. So matinees is going to have to go here. And it's going to be of an A claim. So it's going to be all half-price shows are matinees. So the key is whether it's an only or it's a B only. That's going to determine between a predicate or a subject. Tricky, I know. We'll work on this stuff. Very good. All half-price shows are matinees. Now, here's another tricky element of translating into standard form when we're dealing with times. Consider this statement from ordinary language. I always get nervous when I take logic exams. That should not be true, but how would we state this in standard form? Well, this is a claim about time. Well, times. Any time you take a logic exam, we're stating something about those times. So the proper translation is to state all times I take logic exams are times I get nervous. And you'll notice what we're doing here is creating a category of times, specifically times that you take logic exams. And that becomes a category. And we're now using that as the subject in standard form. So all times I take logic exams are times I get nervous. I get nervous every time I go out on a date with her. How do I translate that in? Well, all times I go out on a date with her are times that I get nervous. So anytime you're talking about a time, you're going to translate it in this form. Here's another tricky aspect of taking statements from ordinary language and translating them into standard form. How about when we deal with single individuals? You've just seen how we handle times. We created a class or a category. With that in mind, how do you think we would handle the case of single individuals? It's kind of counterintuitive, I suppose, but you actually need to create a class. We should treat such claims as if they were about classes with exactly one member. In this case, Aristotle. So all people identical with Aristotle. That becomes a category or a class that we can use in standard form. So if we make a statement about ourselves, all people identical with Kalen are X, Y, or Z. That's how we create a class out of a single individual. So keep that in mind. In order to translate statements into standard form of categorical claims, you're going to have to create a category or a class. When you're referring to times, you're going to create a category referring to times. When you refer to single individuals, you're going to refer to a category of people that are identical with that individual. Claims about single individuals should be treated as A claims or E claims. Why would that be the case?
Since there's only one of them, it can't be like some of them are one way and some of them are the other.
Exactly. Some of the people identical with Kalen are liars. That makes no sense. It has to be all or none when you're dealing with single individuals. Very good, Sarah. All right.
Ma'am.
Now, a false A claim about an individual implies a true E claim, and vice versa. So if we say all people identical with Kaylin are not liars, and we say that's true, then the A claim that all people identical with Kaylin are liars is going to be false. So either the A is false or the E claim is false if we're dealing with single individuals, once again. Unique situation. This is not the case with other A and E claims. If we're dealing with ordinary classes, what we say here is not true. Now, how about claims about objects, occasions, and places? They often require the same kind of translations as claims about individuals. So we're going to kind of create a category once again. Let's take an example. St. Louis is on the Mississippi. Well, how are we going to translate that? You know, just like with Aristotle, all people identical with Aristotle. Well, here we're going to say all cities identical with St. Louis are cities on the Mississippi. So once again, we're creating a category or class, and this category or class is only going to refer to that city. So,
Excuse me.
okay.
I wonder if it's logical to say that all cities that identical, because there is only that one city in that place. If there is Aristotle, there is only one Aristotle. You cannot find identical Aristotle, identical city. It's only one. So I wonder if it's logical to put them in those phrases.
Well, given that the logic text does it, I think it's pretty clear what their answer is. Yes. It might be a little counterintuitive, but this is the only way you can get a statement like that into the standard form of a categorical proposition in a way that is valid and logical. That's because, to be honest with you, this form of logic only deals with classes in categories. So in order to play this logical game, it has to be translated into a class. Now, what they're contending here, the authors are saying that when you translate something about Kaylin into all people identical with Kaylin, those are equivalent. They have the same meaning, and they're going to have exactly the same truth values. So those translations are going to be equivalent in the same sense of equivalence that we discussed right here, eventually, here, right there. So, St. Louis, all cities identical with St. Louis. These are the two things we're referring to. These are equivalent claims, or equivalent things. So if, to be more precise, if I make a claim about St. Louis, and I make a claim, the same claim about all cities identical with St. Louis, those are going to be equivalent.
I understand that. My point is that because there is only one St. Louis,
Right,
there is only one Kevin.
right.
There is no identical Kevin or identical St. Louis. So
Correct.
maybe the place and the person cannot be put in standard form. They may be exempt.
They may be exempt.
Mm-hmm.
No, they're not. And the reason the authors are going to say that they're not is because when we translate Kaylin into all people identical with Kaylin, they're going to say that any claim that has those subjects is going to be equivalent in this sense. It's going to be, I know it's counterintuitive, but if you actually think about it, they're going to be identical. You know, there's no difference because there's only one person identical with Kaylin. So Kaylin and all people identical with Kaylin, that's kind of the same person. That's not kind of. It is exactly the same person. Also, St. Louis, and the class of all cities that are identical with St. Louis, they both refer to just St. Louis. So they're going to be identical. Now let's face it, it's weird, and they are kind of force-fitting these terms into categorical form. But logically, it is valid. Logically, it's valid. Counterintuitive, a little weird, but valid nonetheless. Okay, where? So times, all times I take a logic exam, all times I go out with her. When we refer to a time, we're going to create a class of times, or a category of times. When we refer to individuals, we're going to create a class or category of individuals. And even when we refer to objects, occasions, and places, we're going to create a class. It's going to get even weirder than that. We're going to have to create a class. So with St. Louis, that's going to be all cities identical with St. Louis are cities on the Mississippi. Let's start taking some examples here. Translate them into standard form. What's your major, Sarah? Sarah is an English major. Translate that into standard form.
All people identical with Sarah are English majors.
Very good. Where are you from, Sarah?
St. Louis.
Really?
Oh.
Oh, that screws it up. We need another city. Caitlin, where are you from?
Thailand.
Where?
Thailand.
Thailand.
I was born there.
Interesting. All right. Let me see. Thailand is the city that Kaylin is from. Translate that into standard form for me.
There's no restriction.
What's that?
Yes, I said there's no restriction on the sentence.
Can you say a sentence again?
Yeah, you didn't.
Thailand is the city where Kaylin was born.
Thailand is the city where all people identical to Tyler were born.
Kill it, yeah.
Huh? Oh. I mean, same thing.
I think, Leon, I need to rephrase that. St. Louis is on the Mississippi. Florida is on the Gulf of Mexico. Translate that into standard form.
All cities are identical with Florida.
All states identical with Florida are states that are absolutely. So, once again, what you're doing is you're taking this place, this occasion, this object, and you're creating a class out of it. Yes, ma'am?
I get confused with the place with this, the translation for this. All cities identical with St. Louis are cities on the Mississippi, but there's other cities on the Mississippi that aren't identical to St. Louis.
That's all right.
That's
all right. What we're saying is in this class of cities that are identical with St. Louis, all of them are on the Mississippi. We're not saying anything about cities that are not identical with St. Louis. They can be on the Mississippi or off them. And actually, that's an important thing to keep in mind. When we say that all cities identical with St. Louis are cities on the Mississippi, we're making a statement about St. Louis. We're not saying anything about any other cities. And we need to keep that in mind. Very good point, group. Okay, here's where it gets really weird, Maddo. Boiled okra is too ugly to eat. Boiled okra. First, has anybody had boiled okra?
Yeah.
Is it ugly?
No.
It looks fine. I don't know what their problem is. So, this is invalid. This would be... No, I'm joking. Boiled okra is too ugly to eat. How are we going to translate that? Well, given how we have translated the other situations, you can foresee that we're going to have to create a category here. We should treat the statement as a claim about examples of this kind of stuff. So the translation is, all examples of boiled okra are things that are too ugly to eat. So, McDonald's food is too unhealthy to eat. McDonald's food is too unhealthy to eat. How would we translate that into standard form?
All examples of McDonald's food
Are too unhealthy to eat. Very good. All examples, and once again, we're creating a class which only refers to the subject. That's what we do. We create a class that only refers to that subject. Well, I was going to say French fries, but it's just the same thing. I think you got the hint of it. Any questions? Translating claims into standard form. We're going to work on homework examples. We're going to kind of slowly ease our way into this so that even Maddow thinks that it's intuitive. It's easy to do. Now, here's where I just want to introduce this, I guess, at the end of the class. We'll pick it up again next time. But the square of opposition helps us begin to understand the implications of the different kinds of standard form claims and how they relate to each other. We call this the square of opposition. And so the A claims are on the upper left. All S is P. Then we have the E claims on the top right. No S is P. Then on the bottom we have the I claims. Some S is P. And some S is not P. And this square is meant to illustrate the logical relation between the A, E, I, and O claims. And actually, once you get this square of opposition down, and you understand the truth value of one corner, you may be able to deduce the truth values of the other statements just on the basis of this square. So let's consider, first of all, contrary claims. The contrary claims are these on top. All S or P, no S or P. You know, they're contrary in that they're saying the opposite of each other. And therefore, the logical relation between them is they can both be false, but they cannot both be true. They can both be false, but they cannot both be true. So, if E is true, what can we deduce A is?
False.
Correct. And that's how you're going to be able to begin to deduce the other squares in the opposition. From knowing one corner, if it's the right kind of answer, you can begin to deduce these other parts of the square. Now, contrary claims are only going to refer to A and E claims. That's why contraries are up here. Now, it's all simple, but it just builds on itself, and that's what makes it complex. It's all simple, just like that, but it builds on itself. So how about sub-contrary claims? These are the ones on the bottom. Some S is P, some S is not P. Now, what is the logical relation between these? These can both be true, but they cannot both be false. If it's false that some S is P, then it cannot be false that some S is not P. It cannot be false. That has to be the case. So they can both be true, but they cannot both be false. Once again, now subcontrary claims, subcontraries, that relationship is going to obtain between I and O claims only. Let's try the contradictories. Now these are right through here. A and O are contradictories, and E and I are contradictories. They never have the same truth value. Yes, Vivian?
We don't have that, the one you're using now in our shop now.
What do you have?
We have like entails, and I tried to check the one that.
You know, you're right.
We even have that.
You know what I'll do? I'll post this PowerPoint. I edited this to improve that, and I think I posted an old version there. So what I'll do is after class, I'll replace the PowerPoint on the website with this new version. That'll have this square. Thanks for pointing that out to me. I must have got that square from an older version. But once again, contradictory claims go across here. And their relation is they can never have the same truth value. So if A is true, what's O?
False.
False, right. If E is false, then I must be true. And you can begin to see how once you learn one of the corners, you can begin to deduce all the others. And contradictory claims refer to all of those corners. A, O, E, and I. All right. I threw a lot of information at you. We'll pick it up here on Thursday, and we'll work it through slow so that we can all understand this stuff. Thank you.
Take it easy.